Tiny camera has a very wide angle.
Yeah, well, it's a really 360 camera, so there's two on each side. Sorry. And what is it? Yeah. You're on camera. Ironically.
Is it a specific brand or something?
I don't know which brand it is.
Insta 360.
It's an Insta 360.
It's like one of the top ones. GoPro has one too. Maybe DJI.
I don't think that's the latest one.
Yeah, those are maybe the three big ones, I think, for 360 cameras.
But it has a dome-shaped lens.
It's not. It just says it's recording. I know. Confusing, right, Greg? How couldn't it be blinking green?
You extend.
Yes. It's terrible.
Make it yellow.
Yeah.
No, it was my hands on.
Oh,
1 or 2 minutes still?
I only have so much length. So,
I think it was just a, hey, these are
Probably, yeah, 2 cameras.
I was interpreting it that way, but it occurred to me that sometimes I'm not necessarily with social cues, and I was wondering maybe, like, here, really, please do. I wasn't sure. So you don't know.
yeah.
Very much like
Great, were you trying to repair it or were you driving?
We'll be in as soon as a month from now.
You should think I would have to do that.
Make it stick around it without lifting.
Oh, we know. We met
all of that.
All the alarms.
It's per meter.
I'm aware of this.
Yeah.
We really
I would want some aggregation. I think we'd want to roll it up and look at those aggregation.
top slowest.
All right, everyone. Hello. I'm gonna get started on time. My name is Luke. I'm a software engineer working on search infrastructure at Bloomberg. Just a brief intro to Bloomberg. Bloomberg is a financial technology and media company. The main product we sell is called the Terminal. Hundreds of thousands of financial professionals around the world use the Terminal every day for information, news, financial analytics, that kind of stuff. And one of the ways they get this information is through alerts. Alerts is a big pillar of Bloomberg functionality, probably why I'm talking about it here today. But first, just take a step back. What do I mean by query alerting? So we're all on the same page. On the slide here is a screenshot of Bloomberg's news application. The interface is pretty simple, right? You have a search box. I've typed in robot wildcard and Tesla. I'm interested in Tesla robots today from the news. On the right-hand side, I have some filters where I can select certain news sources over others. I'm interested in only English language news in this particular case. So I run the query around noon. I get back some news in time-sorted order. Great, I'm looking at the latest news on Tesla robots. But at 12:12, CBT News publishes an article about Musk betting the future of Tesla and robots. And the backend of this application figures out that I have a page open with a query that matches this document and pushes the document to my page. I didn't have to rerun the query. Basically, this is what I mean by query alerting. It's tracking the search, tracking the query, and when new documents come in, matching against them. And then the notification mechanism here is secondary. This app also supports email, messaging app, whatever you want. Talk will be focused on the actual matching. And just to give an idea of scale, let's say we have like 100,000 users of this application. So I'm gonna reference this example throughout, just as a baseline, when talking about the solution. So in the talk, I'm gonna talk about some existing solutions to this query alerting problem. I'm gonna focus on one in particular called Apache Lucene Monitor. I'll talk about certain strengths and optimizations it has in detail, and then I'll talk about limitations you may face when you use it. Then I'll introduce the Solr State Search module, which is an attempt to address those limitations. It hasn't been upstreamed yet, so it's like actually Solr State Search in quotes. and then I'll put my claims to test with some benchmarks at the end. So we want to look at the existing solutions first. You don't want to reinvent the wheel. See what we have in the toolbox for this problem. It's not a cutting edge problem. So the simplest thing you can do is save those searches in a database, and on a periodic interval, run through them, all of them, by brute force against your document search collection, filtering for only maybe the recently added ones. So if you want to have that real-time aspect of the example that I set out, where you kind of expect the news to pop up immediately, you have to make that interval really short. But if you have hundreds of thousands of these, it's going to be very expensive for you as a technology provider to scale up your search infrastructure to do this on a tight loop. Now, of course, you can stretch out that interval and run through them after a long period of time, but then, picture you're a trader looking at that news application with certain security that you're interested in, stock that you're interested in. You miss some big news information or it's delayed, it might be costly for you. So the first solution is costly for us. The second one is costly for the client. If you can get away with it, it's great because it's simple, but in this case, it just won't work. So there's a thing called Percolator within Elastic and then OpenSearch that stores queries in an efficient way in what I'll call a query index. Pin that for a moment. And it effectively lets you do that without that brute force approach. Stores the queries in an optimized way and searches with documents. This makes sense if you're already in that ecosystem. One thing that's kind of a bit of interesting trivia is that Percolator code, the stuff that makes it smart, is in Percolator. It's not in Lucene, it's not Apache code. So Apache conference, we're gonna skip over it. But it'll make a comeback. All right, so the final solution that I will talk about today regarding this problem, the existing one at least, is Lucene Monitor. It's a reverse search library, so similar optimizations that Percolator has, just in a different place. If you're using Solr already for regular search, this makes sense because you don't have to add another tool like Elastic or OpenSearch just for something that's usually an auxiliary thing. Like usually your main focus is your document search, and this is kind of an add-on. So because it's at the Lucene layer, the translation from your Solr domain to the Lucene domain, it's not trivial, but it's also not rocket science. You do some legwork, you can get it done. And I'm going to go into a little bit into the implementation details of Lucene Monitor because Solr's saved search will build on it.
Can I just ask a little history name check? There was something called LUAC.
Yeah, sorry.
Yeah.
Good call. All right. Lucene Monitor was originally called LUAC, developed by a company, Flax, former company Flax, and contributed to Lucene. Good call. Just to get the genesis. All right. So the pre-searcher is a component within the Lucene Monitor that I will call its brains, and it effectively converts queries to documents and documents to queries. Why? Because, well, I was saying you have this query index, right? If you try to add a query to index writer, your compiler will be mad at you. So what the pre-searcher does is it effectively it takes your query and converts it to a document and using some magic. And it does the same thing, well, if you wanted to search the query of the index searcher with like a document, again, you would get not very far unless you have something that can convert it to a query. So that's kind of the high-level interface of the pre-searcher. And it is an interface. There are many implementations. I'm going to go through a simple one just to give an idea of how it works under the hood. So imagine you're in the world of single-term queries. Super simple. So we're looking for the string robots in the field story text here. Well, a Lucene term is really just a field and a value, right? So the translation to a document is pretty straightforward in this case. You take that term and you make it into a field value. Since your document is a collection of field value pairs, it works fine. So again, you're trying to index this query, your document representation of that query is almost identical. Documents are a little bit trickier to convert to queries. They're by nature multi-valued. So even a simple example like this with just an ID and a text field, you can pretend that text field is going to have white space tokenization. So it's going to get split into maybe 5 tokens there. So you have some values. And if you're trying to find all the queries that have any of those values, one thing you could do is just OR them together, right? And you take a disjunction over all those terms, all those values, ID 0 or story text it, or might, or be, or the, or robots. when you query it, you're going to find that document that comes from that query that you've indexed. Basically, a nice little property emerges here, where if the query that you generated from the document that you want to alert on matches the document that you generated from the query that you've indexed, then the original query that you've indexed is guaranteed to match the document that you want to alert on, and vice versa. This also applies to pure disjunctions over term queries. So if your index was full of only disjunctions over term queries, this would also work perfectly. Unfortunately, it breaks down for even something simple like an AND, a conjunction query. If you're looking for robots and rise, and you're trying to index it, well, first you notice you don't actually have to index both of those terms, but you do have to index one, and you have to do that at index time. You won't have the choice to make that decision later on. So let's say you choose to index the term robots to represent this query. If a document comes in that you want to alert on, same as before, it gets broken up into that disjunction. Robots matches robots, but the original query, robots and rise, does not match the original document. So the way you get around that is just you add another step, right? You say the pre-searcher, hence the name, pre-search, will filter out what it knows cannot match. So in that example before, if in your index you also had a query that looked for kangaroos or tulips, they wouldn't be in the result at all, it'd be filtered out. So it does still remove certain results, but it's not perfect. And because you acknowledge that, you actually do a final verification at the end, where you resolve the query that corresponds to that document, you read it from a cache in memory, that's an implementation detail of Lucene Monitor, and you run each query that passes the pre-search step against the document that you want to alert on. The reason you keep them in an in-memory cache is because most often this process is constrained in terms of performance at the matching step. So you have to get the query from somewhere, like a capital Q Lucene query, you need it. The only way you could get it otherwise would be to decode it from the index somewhere. But because that takes time, we don't want to add any more CPU cycles to this. Lucene Monitor decides to keep them around in a map, so it doesn't have to do this every time it does a match. So, that's great, but there are certain issues, side effects that result from keeping every single query in a data object in heap memory. One is really slow startup times, because Lucene Monitor requires every query to be in the cache. You have to load them all up when you start up from the index. You have to do all that decoding, and at a scale of hundreds of thousands of queries even, this can take minutes. And the other thing is, your heap memory footprint grows linearly with the size of your index, which might be surprising in some way, but effectively puts a pretty tight vertical scaling limit on this thing, because you just have to increase heap memory. At a certain point, that's going to become ineffective. And there's a final issue with the Lucene Monitor map, the cache, and that is the query cache, and that is that you have to block while you update. So effectively, because there's a strict requirement that each query must be in the cache, if you write to the index, you also have to update the cache. And then you have to commit, because the index cannot be out of sync with the cache at all. And you have to do all those things atomically, and so you grab a lock. And you might think, hey, that's not terrible, there's a critical section here in my update, there's a lock, whatever. But it actually also blocks the query threads that are trying to alert with, that are carrying those documents that they want to alert on. If the query continued with matching while this was in progress, in flight, while let's say you've updated the cache but you didn't commit the actual changes to the index, the results would be incorrect. They would be potentially skewed. And the final point here is about limitations is, how do you scale this? In today's world, we're expected to run systems that are highly available, so if one process goes down, obviously the system should continue. Any kind of application that's wrapping a Lucene Monitor query index is going to be stateful, and replicating stateful applications is much harder than replicating stateless ones. And so you have to build your own logic, because Lucene Monitor doesn't have anything that will replicated by default. Same thing with sharding. That could have helped the kind of the hard vertical scaling limit regarding that linearly growing memory usage because of the cache. You could shard it into two, smaller query indexes that you would delegate to different processes. But again, if you do that, you have to do it yourself because Lucene Monitor doesn't have any kind of support for this. And at Bloomberg, we do this a lot, and I've seen a lot of tools that have tried to do both of those things. And it does get complicated. And being on the search infrastructure team, we're a big user of Solr. The question is, like, if only there were a tool that could replicate and shard Lucene. And at Bloomberg and many other places, that's Solr. And that was the motivation for state search, which is, by the way, a pretty old JIRA, probably 12 years old at this point. So people have been asking for quote-unquote percolator in Solr for a while now. And this is just another attempt. So I'll lay out the vision of what it was supposed to look like, the integration that is into Lucene Monitor into Solr. So one, we don't want to reinvent the wheel. So Percolator does its own thing in Percolator land for historical reasons. But we have Lucene Monitor now to rely on. Let's try to use it since we can. Two is, at the same time, we want consistent behavior. We don't want certain implementation details of Lucene Monitor to have it create negative surprises for the users of Solr that aren't necessarily, they're really a consequence of implementation details and not necessarily truly necessary to do this kind of thing. And two, we want to keep the integration simple. So again, this isn't like, in my view, this should have been a really thin layer converting queries to documents and documents to queries. It shouldn't really require surgery to like Solr Core and Lucene Monitor to get this done. So that was the idea when I started with this, but it crashed into reality a little bit. So one is Lucene Monitor has very tightly wrapped index components, like the index writer. The way it creates searchers is very much wrapped up tightly, and you can't customize it in any way. On the flip side, Solr is opinionated about these things. In fact, it has its own implementations of index writer and the searcher. So swapping those out would require a good bit of change to different libraries and modules. Also, those cache issues that I highlighted, it would be sort of a negative shock for a user of Solr to find out that they have to walk on eggshells with this state search collection because they can't put any more than a couple 100,000 of documents into it or queries into it because it's behind the scenes loading this in-memory on-heap cache. And the other thing is the blocking reads and the slow startup times. Again, not very Solr-like. So to get around this, we're looking if we could like peel back that outer abstraction layer of Lucene Monitor, which encapsulates these things like the index components and the cache. And if we could reach through, but beyond that advertised API, potentially, using a slight implementation detail of the Lucene Monitor library, which is the pre-searcher, which by the way has a very simple interface. Again, it's just taking queries and giving you documents and vice versa. And that way you could avoid the whole state management bit of Lucene Monitor, which works great for like small applications, but doesn't really fit well into something like Solr. And I said, oh, well, we reached through and we ignored the cache and all the stateful things. Does that mean we don't have a cache? No, we reinvented this wheel a little bit, but we're going to use Lucene or Solr's version to make it a little bit more flexible. And a bonus is Percolator doesn't have a cache of these queries that it resolves during matching. It always just decodes them. And it does have a significant impact on matching performance. So the states, I'm going to give a brief overview of how the state search cache works in the proposed world. So we're running through the matches, and thank you. I don't know, he's not here, but he went through like a lot of this stuff in his talk before. But basically, as Lucene is processing documents, it's going, Lucene doesn't know that this is like a safe search collection. So it's going doc ID by doc ID, passing the doc IDs that have passed through the pre-search phase. And those doc IDs, those Lucene doc IDs, map to Solr IDs and Solr versions, and you can look them up. And using the Solr ID, you can look up the query in this cache, and there's an entry associated, in the entry in the cache, there's also a version associated with that ID. And if the versions match, you know that you can use that cache query. It's the same, it matches the segment. It's good to go. And 99% of the time, this is the branch that you take. It's almost identical to Lucene Monitor, but you do have to look up that extra version field. Although in practice, the matching far outweighs that extra lookup in terms of total time. But it also has the flexibility to say, oh, the versions don't match or it doesn't exist. You can decode the query from the index in that case. And you also ask whether the cache is behind the current segment you're in, because it can be. And if it is, you'll want to update the caches going forward, most likely. That's the query you want to hold on to and not the old one that's out of date now. And finally, you would use the decoded query. So what I described in the previous slide is lazy cache loading in a nutshell. If you remember, Lucene Monitor does it eagerly. It does it right when you give it some queries to update. So the way that we did this for the way we achieved the same or near similar effect with Solr Safe Search is through what I'll call the eager cache warmer. And basically, again, like just quick rehash, when you're adding documents to Solr/Lucene, every time you do a commit, you open a new segment. You might open a searcher that is basically a view of the index at that given snapshot point in time. There's some caches associated with that searcher you can configure, and you can also configure like a warmer method that lets you warm the cache before you say the searcher is good to go. And optionally, you can have this warmer where the cache keeps track of the last max point, the last max version that it knows about in the query cache for a particular segment, and it queries for all the queries that are greater than that version. So it basically incrementally builds that cache as you're opening searchers. It would be impractical to rebuild this cache from scratch every time, because that would make opening up searchers super slow. So you kind of have to do it incrementally, but because it's versioned, you can share it across searchers safely. All right, so I've talked about the guts of the thing, certain implementation details, but how would you actually use it? So the idea is, if you want to add a query to a safe search collection, you use the update endpoint, and you get all the replication and metrics associated with that that you would get from Solr. So now you have some queries in an index. Lucene thinks they're documents. Solr basically thinks they're documents. And one way you can query that set of queries is with a document here. Again, you have to configure those components that convert queries to documents and documents to queries. But once you have that translation layer in your Solr config, you can do something like run select against this query index with a set of documents and get back as a Solr doc list the list of queries. There's a slight hitch to using the select API for this. So typically with like a regular search workflow, you only care about the top end documents. For reverse search, in my experience, most of the time you want every single query that matches the document. And so to get around that, you could set the rows parameter in Solr to something very high. Rows tells you how many to fetch at a given time, and hope that it gets all the queries that have matched. But the more I thought about it, the more I realized there is already a mechanism within Solr through the streaming API that can do this in a more idiomatic way, so that you're not hacking around the interface, setting rows to something very high, and instead by default getting every single result. And unfortunately, I didn't benchmark this, but I did some cursory benchmarks for a case where we want to return 250,000 matches. This would be kind of unusual in a real system, but Who knows? And in that case, streaming does really outperform select 4 times in terms of latency. I was impressed by that. I don't know how it translates to smaller results that are probably more likely to come up in the real world, but that's something to figure out later. So to highlight the key differences between Solr State Search versus Lucene Monitor, one, it's that flexible cache. You have the option of lazy versus eager cache loading. In theory, you don't even need to use it. You can do what Percolator does, which is decode every single query at match time. And it can store a subset of queries. I think with the lazy, if you're not doing eager loading, what you find is 80% of your queries are barely ever going to be matched, so there's no sense in keeping them around in heap memory, right? And the other difference is you get Solr batteries included. This is no thanks to me, but basically by plugging it into Solr, you get replication sharding and streaming too, which you don't get with Lucene Monitor. All right, so with that out of the way, we'll proceed to benchmarks. The environment was Java 21 with a 31 gig heap. We're trying to give Lucene Monitor kind of a head start. Solr, the Solr version is 9.8, Lucene 9.11. There haven't been many advancements in Lucene Monitor since 9, so I think it's pretty safe to assume this is to be similar with 10 or 11. Operating system is Ubuntu. We run these processes in a containerized environment, and they have 16 CPU shares each. Test configuration, basically because Lucene Monitor is a standalone thing, the baseline is a 1-shard, 1-node Solr cloud. Compare it against Lucene Monitor standalone instance. But then we also compare that with a 2-shard, 2-node to see how it scales horizontally. We had to do some tweaking to the segment merge policy because, again, this is a CPU-bound thing at the matching layer. So if you can parallelize the matching across many segments, you do get some latency improvements. We configured it with that eager cache warming, so it's as similar. We configured Solr State Search with the eager cache warming, so it's as similar as possible to Lucene Monitor. And Lucene Monitor was configured with persistence enabled, so it's mirroring more Solr, which that is what it does by default, and has a parallel candidate matcher. So again, the matching can be done for a single document on many threads. The way it does it is a little different across the two, but both of them are using multiple CPUs per document, potentially.
Quick question. Are you saying that you made sure that the segment count was the same on both sides?
No.
You did not do that?
No, I did not make sure of that. I had it, so Lucene Monitor doesn't care about segments. It does. Its parallelism is like at a collector level that is like aggregates multiple segment results and then parallelizes, and it's basically like a filtering collector. Whereas the way Solr State Search works right now, the only way you get parallelism isn't through anything in State Search, it's through like the default mechanics of if you want a multi-threaded equals true flag, and then you use all the Lucene internals of parallelizing that. So it's a little bit different. And again, we're running this with like 10 threads at once, submitting documents to this system. So first we're gonna walk through the throughput. Here on the y-axis we have how many documents or queries per second, how many documents per second we're matching. And on the x-axis we have collection size and queries. So going from 250,000 and doubling to half, then doubling to 1 million, then doubling to 2 million. The blue curve here is Lucene Monitor. The orange curve is the 1-shard, 1-node Solr State Search. What surprised me, but I wasn't able to replicate a few times, so I'm more or less confident, is that actually the throughput is better for Solr State Search 1-shard, 1-node. I think it comes back to the way parallelism is implemented. It's more fair in Lucene Monitor, whereas in Solr State Search it's like segment-based. So on average, in this particular test setup, throughput was better for Solr State Search. The differences converge at the larger sizes, which also surprised me. But the 2-shard 2-node, I think, is the more interesting curve, and it's basically showing that this scales horizontally pretty nicely because each point at the Solr State Search 2-shard 2-node corresponds to the half point, so 1 million corresponds to the 500,000 in terms of throughput. So it's scaling horizontally really nicely, and even better for 2 million as Solr Safe Search, one shard, one node, and Lucene Monitor started to struggle at that scale. At 1 million and 2 million respectively, they started to struggle a little bit. I'm going to call out an asterisk. I disabled the eager cache loading for 2 million for Solr Safe Search because it couldn't start up. It OM'd. And Lucene Monitor was teetering on the brink, and the next chart will show that too. So this one is P99 latency. Lucene Monitor is better than Solr Safe Search, one shard, one node for 250,000, 500,000, and 1 million. Definitely better, like worst case / P99 latency here. But at 2 million, because it's starting to, it has to keep everything in memory, it starts to run out of memory and it goes into long GC pauses. Old gen collection, it takes sometimes seconds. So the P99 latency actually overshoots Solr Safe Search, which is more flexible because it can do lazy cache loading if you need it. And Solr Safe Search 2 shard 2 node, also the latency is increasing kind of linearly there, but the P99 latency at least, but at a much lower slope than the one shard one node. So again, indicating that horizontally scaling this is pretty viable. Startup. This is one of my pain points. Starting up these things is really slow. So Lucene Monitor takes 127 seconds, 2 minutes, over 2 minutes, to start up a 500,000 query collection, or query index. Solr Safe Search takes 162 seconds. So it looks like I made things worse. And the reason is partially probably because it has to do that version field lookup, but there might be some other things that I'm missing here. But one thing that both of these implementations have in common is that they read the cache, they update the cache in single-threaded fashion. But with Solr Safe Search, you don't even have to add any code to the module. Solr, you can just split it into 2 shards. Those will be 2 different Solr cores, and you can load those up in parallel just by default. So it cuts down the startup time from 162 seconds to 89 seconds, even with eager cache loading enabled. And then finally, you can disable eager cache loading, which I recommend. But and it brings it down to still slow, but more reasonable 4 seconds. So concluding thoughts, Solr Safe Search can scale Lucene Monitor to potentially millions of queries. It's convenient if you already use Solr for document search. I think that's one of the main selling points actually, because you don't need another tool. You don't need a mapping from a Solr domain to Lucene domain. It's just like, it's the tool that you know. And if you're interested, look at the PR. I've also linked the JIRA there. And I just wanted to give a special thank you to Christine Porschka. She spent a lot of time on that PR and gave me valuable feedback, so just wanted to express my gratitude. And yeah, thank you all.
One little thing I thought was cool. I was looking internally and I saw that Bloomberg contributed 6 patches to LUAC, which became Lucene Monitor. So we've so we have a history of contributions to open source. It's nice to see.
Yeah, I think Bloomberg is one of the bigger alerting use cases, so it makes sense.
I just want to make sure I understood the use case. So in your example, once there are new documents in Solr, you also want the match to appear in your app, right? So it's as if
there is no bridge between indexing into a Solr, like that isn't what the solution is.
not about solution, the use case. So something
use case,
new comes up, like a new news article, and you want to see the match. So it's as if you want to run the known query on the subset of documents which have been appended.
Yep, that's right.
So like either with a timestamp filter, I'm just imagining, for example, or just on these documents in isolation.
That's right.
So is that the accurate statement that this is the use case, or am I missing something?
That is, like, I feel like you're describing the use case, but you're also describing an implementation method. So I think what you're describing is similar to what I suggested in the scheduled polling slide, which is an option. It's actually kind of far behind. Am I not sharing? Oh, great. What happened?
So I think that what he's getting at is, yes, you're trying to get that latest match. So any news stories in this case that match the query that you originally had, you want to see those as close to when that news story was indexed as possible.
Correct. And like one nuance may be, do you want to run the query on the entire collection to get the proper ranks of all the results? Or is it okay to just
if
get
you're
the...
doing a scheduled polling approach, yeah, you might only do a subset. But again, if you have hundreds of thousands of queries, you'd have to like run through them all, right? So it works sometimes, but sometimes it doesn't in terms of performance.
So I'm not sure if I missed something in what you were saying, but you have a concern with getting an alert on this and then not having actually showed up in the index, so that if they rerun the search or do something based on that alert, they don't yet see it on the search. Is that a possibility?
You're saying that they run a search and it immediately pops up like...
So you're alerting so fast that you're giving them the information before it hits the index.
Updated your cache before the document got committed or something?
Well, I'm not quite sure if I understand whether or not it has to actually have been committed before you send your message.
I mean, do your search every...
the query committed to the query index. It can be. Like if you in that example, yeah, sure, you could send a commit after your query update, and then that guarantees visibility. That is like an option. Right. In some scenarios, you might not need that. Like in other cases, that might be redundant. Like let's say you're re-ingesting a bunch of queries because you have some dynamically generated list, and you don't really care about like committing like eagerly there. Then in that case, maybe you wouldn't eagerly commit. So it depends.
I'm just curious because this case of query matching is kind of interesting. I mean, there's relationships among the queries, right? Like I know, for example, if it matched red and robots, it's also going to match all the queries for robots and all the queries for red.
Yeah.
Can you make use of that information in any way? Like I just don't know. I just feel like there's a lot of structure among the queries in the cache, so that you could potentially like reduce the in-memory cache to, I don't know, aggregate your queries together in some way.
Interesting.
I haven't really thought about this for more than 2 minutes, but
just unique terms in some way.
Like share the terms, like.
Yeah. Well, like if you have hundreds of thousands of queries, right?
Yeah.
Then obviously some documents are going to match lots of those queries.
Probably 50 people are watching Tesla.
Sorry.
Probably 50 people have a query that has Tesla somewhere in it.
Yeah.
Right.
Yeah. And I don't know. Maybe it's not worth.
That's an interesting thought. Like, kind of pool those references, like.
Well, I think you had this idea that you would have some queries that are hot in your cache and other queries that you would have to like fully evaluate or something like that.
Yeah.
But I mean, one thing you could potentially do is for the queries that are hot in your cache, if some of them imply queries that are not in the cache. Then,
eagerly load them only in that once you hit that.
Yeah, or you could just like first go through your cache and then, expand to all the other ones that are kind of like implied by those.
Okay, that's an interesting thought.
And then you wouldn't have to reevaluate them. I don't know.
Yeah. Well, but the question is, okay, you know that they're correlated based on the document, or just in general that they're correlated?
I think just based on the structure of the queries themselves.
Yeah, maybe.
Because they're like Boolean queries. So like, like A and B is, like A is always going to be true if A and B is true, and also B. Like if I have...
Right, in order for red Tesla to be a match red, if there was a Tesla query that has to match too, right? That's the way.
Yeah.
I think there's a lot of optimizations that can be done to reduce the number of overall queries and the amount of work you have to do per query. The thing is, this is a remarkably trivial example. People get really complex with these things.
There's many pre-searchers. I gave a really simple, naive example. There's like pre-searchers that handle conjunctions, intersections much better than what I've done. They require a little extra index space, but they're more efficient. A little hard to explain in 40 minutes.
And are there limitations on the types of queries that can be?
As long as you have a query parser that your Solr cloud knows about, I don't see what the limitation. One thing that isn't implemented is like default fields. Those are kind of useful sometimes because they shrink the query, at least as it's serialized, but I don't think I did that. But in general, it should be pretty one-to-one because you just need something that parses the query. That's really And then like deconstructing it, it's mainly optimizations over term queries and Boolean queries, like any combination thereof. That is, and like disjunct. There are certain other things like disjunction of X queries that it also handles. The library does, Lucene Monitor as of today. But if it encounters a branch of a query that it doesn't know how to handle, it effectively there's a way it ignores it safely, in a safe way. But it focuses on the optimizations in the term and Boolean space. And that's mainly where the optimizations lie. So if you're doing a bunch of even wildcard or non-term like range queries, there isn't any good optimizations for those cases right now with Lucene Monitor. Yes.
What percentage of your queries the matches get filtered out? Like you have a fast match, you get a set of queries, then they get eliminated with the true matching?
Yeah.
How?
In a good system, I'd say about 50%. Like that's like a good, I call pre-search ratio. I don't know if that's a technical term, but I've seen ones that are bad where it's like 5%, and then like, yeah, you're matching 20 times the queries they actually return. So it really varies.
And if that's low, then you sort of go back and figure out, you have to reconfigure the pre-searcher.
You tune the knobs of like, figuring it, usually sometimes it comes down to like rewriting the query in a way that's more amenable to the pre-searcher. That's the annoying part. Sometimes I've been thinking about like ways to maybe handling negations better. Right now they're not handled well, but that's kind of tricky.
Do you try to educate your users to express different queries?
It's case by case.
Some of the, if you don't mind, some of the things you mentioned, are those optimization potential improvements for Lucene Monitor?
Yes,
Right.
absolutely. Most of the so the Solr integration is like a shell, and it has that caching thing, but that's about it.
Yeah, okay. Just check. The number surprised me, by the way, at 50%. Like that's not great. You're running on half of that. I don't know.
Well, you're matching, but half are passing. Like I don't know. In practice, it's hard.
Well, it's something. It'll take what you can get, but I was hoping for
better
dramatic numbers. Yeah.
It's a hard problem, inverting queries.
Yeah, you can look at the Lucene Monitor library. It's pretty dense in terms of like walking the query tree, deciding which terms are relevant, etc.
And it gets harder when Lucene adds things like dimensional points and
Right.
vector search. Suddenly you have to figure out how to invert these things too.
So vector search is an interesting one because it's not like a binary, it's not like a matches dozen. Maybe like the radius. There was a talk last year about radius search. Like in that sense, it could be, but it's a little bit of a different angle, I think. But yeah, the points definitely no optimization so far. In theory, you can imagine some, but nothing contributed yet.
We have one more question.
Oh yeah.
So for every new document update,
Yeah.
it translates into a query for the Safe Search collection. Do you run into like any for high ingestion modes?
Yeah.
Are there any like ceilings or like from your experience, is there anything helpful?
We've only tested this on like certain load tested benchmarks. It's hard to say. It depends. Like it depends on what your query index looks like and how much resources you have. It depends on the types of queries more than the documents in my experience. Unless you're, the one caveat to that is your documents are huge, you have to analyze them. So that is one thing to consider. If your documents are huge, that might be a non-trivial part of this latency. Most of the systems I've seen that they aren't huge enough to make a difference, but there have been a few, and there are ways maybe to save like the result of the analysis and pass it in, like pre-analyzed field or something. But those are like extreme advanced.
If you have a huge document that's being indexed,
Yes.
and you want to see what queries it match
Correct.
yet, then do you generate a gigantic Lucene query from the document?
I skipped over that. There's I didn't have enough time, but there's a thing with it. So the main thing in Lucene Monitor is the pre-searcher. The other thing is called the query term filter.
Okay.
And it basically keeps track. It's a bytes hash that keeps track of the terms
that are in the query.
the terms that are in the query index, and usually it's a much smaller distribution than in your document index. So you end up throwing out like but that's a good question.
The highlighter has something similar, by the way. I worked on that. the unified highlighter, because it sometimes also uses a memory index. But we know what your query is, so why put every word in the document in the memory index when only 5 are in your query? Yeah.
Yes.
Is there a way to differentiate between, say, like a new document versus a document update? Just in case, like.
So you're talking, so again, this solution doesn't delve into like, you add a document to your search index and now have it trigger something. That would be cool. That isn't what this is. That's a hard, trickier problem. Like, have I just reingested this document, or is it truly a new document? Maybe you do it on some date field, like a datetime field, like when it was added. I don't know, but that's not that in practice. Like, it's not what this handles, but maybe someday there might be an integration that
Your original
bridges those.
setup was you had a search and you were going to add the result. So you're triggering something there, right? It has to go out and add that result to the person's UI, right? So something's being triggered already.
Something's being triggered already.
The index of the news document is the trigger.
So okay, yeah. The example I gave is not like it's not just the solution. That's not like the update, the logic that is this an add or is this an update or is this reingestion? That's at a different layer than this.
Right.
But it does happen for sure. Yes.
I'm just trying to make sure I understand the setup of what you've done here, because when you first started out, you showed a search that somebody had done, right? And some results.
Yeah.
And you said that your goal was when the document comes in, you want to add that new thing to their display.
Yes.
Right. So that means you're triggering some sort of thing to go out and add it to the display. The UI has to find out somehow, right?
Yeah, the ingestion pipeline of this application would recognize that this is a newly published thing, and it would send it to, let's say, something like this.
Right.
Find all the queries that it's saved, and maybe there's some additional metadata attached to them. One is like, oh, this relates to a page, and it would fan it out.
Right.
At that age, but this solution doesn't do the fan out. It's just the matching.
What about deletions? Like if I delete a document, should I remove it from the
cache?
Alerts that people are seeing today? You know what I mean? Do you have to know
if it's
that
retracted,
I alerted these people about this document when it matched a query, but now that document has been retracted?
That's a good question. Yeah, I would have to think about that one.
Well, because if you do that, you have to get the search out of the previously indexed version of the document, right? You have to pull it out of the index. I mean, I think it's something you would want to avoid having to do, but I just was curious.
Maybe once in a while you do like a cleanup poll, like to make sure it's sane still. But yeah, that's or you could do it eagerly, but that would be complex.
How is it ranked in the UI when there is a hit and it's inserted in the terminal?
Yeah.
So
that was time sorted. Yeah, so like that's the default sort there, and that's why it pops up at the top.
Okay.
Yeah, I forgot to mention that too.
I think that's all the time we have.
Yes.
All right.
5 minutes over.
Thank you.